Yeah, hello everyone. A very good evening. So let's wait for 5 to 10 minutes so that everyone can join this session. Hello everyone. Hello everyone. Are you able to listen me? I'm audible. Uh, Please let me know once. Actually, I am facing some my system related issue. So if I'm not audible and visible, so I can take the session later on. I will request NPTLD. So hello. Can anyone confirm it once? Okay, I'm visible also. My PPT is able to. Are you able to see my PPT and other things? Okay, so I'm starting once again so that that flow can be on. So, hello everyone. My name is Pooja Verma. I'm PMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Shyamal Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 5 live interactive session, signal processing techniques and its applications. Okay, so you can use chat box for asking and interacting. And I hope all of you gone through the lecture videos. So, topic of this week 5 is properties of discrete Fourier transform. So first property is periodicity. If x of n is a sequence and the endpoint DFT of the sequence is x of k, then the periodicity property will be like this: x of n plus n, where n is the endpoint DFT, is equal to x of n for all n. And similarly, x of r n plus k is equal to x of k, where x of k is the endpoint DFT of x of n for all k, where r is an integer. And another property is linearity. So x1 of k is the endpoint DFT of x1 n, and similarly x2k is the endpoint DFT of x2 n. So what is the linearity property? It follows the superposition theorem. So where a1 and a2 are constant, so if a1 is multiplied by x1 n and a2 is multiplied by x2 of n, then what will be that endpoint DFT of this sequence? This is the a1 x1 of k plus a2 x2 of k, where x1k and x2k are endpoint DFT of sequences x1 of n and x2 of n. Okay, and next property is DFT symmetricity property. So there are four parts: circularly even periodic, circularly odd periodic, and conjugate even periodic and conjugate odd periodic system. So what is a even signal? So all of you know that a signal is said to be even if x of n is equal to x of minus n. Okay, so the even periodic signal is xp of n is represented by the xp of n is equal to xp of minus n is equal to xp of n minus of n. Okay, similarly, circularly odd periodic signal is represented as xp of n is equal to minus xp of n of uh, x of n. It should be it should be xp of minus n is equal to minus xp of n. So it will be the equal to x minus xp of n minus of n. And similarly, if conjugate even periodic and conjugate odd periodic signals. So here must be a conjugate xp of n is equal to x xp conjugate of n minus of n. Similarly, odd periodic signal xp of n is equal to minus xp conjugate of xp n minus n. And DFT symmetry property for a complex signal. What are the DFT symmetry property of a complex signal? A complex signal is represented by real part as well as imaginary part. So x of n is equal to x of r of n plus j x I of n, where n varies 0 to n minus 1. Similarly, the n-point DFT of the complex conjugate signal is x of k is equal to x r of k plus j x I of k, where x of r k is a real part and x of I k is equal to is imaginary part. Okay, so what will be the real and even sequences? So real and even sequence x of n is equal to x plus n minus of n, where n varies 0 to n minus 1. And for real and even sequences, the imaginary part will be equal to 0. So the DFT becomes only if you go through the if you have gone through the lecture videos, there has suggested the real part and as well as imaginary part. So in that case, if imaginary part will be the equal, so that will come only, where the DFT becomes x of k is equal to summation of n is equal to 0 to n minus 1 x of n cos 2 pi kn divided by n, and where k varies 0 to n minus 1 and n is also varies 0 to n minus 1. The DFT will be the finite sequence only. And if you find inverse DFT, so it will be the x of n is equal to 1 by n, k is equal to 0 to n minus 1, and xk cos 2 pi kn divided by n, where n varies 0 to n minus 1. Similarly, for real and odd sequences also, the real and odd sequence follow this property x of n is equal to minus x plus n minus n, and in this part the real part will be the 0. So what will be the DFT of this sequence? Xk will be the minus j summation of n is equal to 0 to n minus 1 x of n sine 2 pi kn divided by n. In this part, for real and odd sequences, xk is the imaginary part, and inverse DFT will be the j is equal to 1 by n xk sine 2 pi kn divided by n, where k varies 0 to n minus 1 and also n varies 0 to n minus 1. Okay, so and what will be the imaginary sequence for DFT? It will be represented as f of n is equal to j x I of n. The real part will be the 0. So for imaginary real and odd even part and imaginary sequence and imaginary and even part and odd part similarly. So the for real part it will become like this: n is equal to 0 to n minus 1 x I of n sine 2 pi kn divided by n, and imaginary part will be the x I of k is equal to n is equal to 0 to n minus 1 x I of n cos 2 pi kn divided by n. For imaginary sequences, x r k the real part is odd and x I k is the imaginary part will be the even. Okay, the circular another property will be the circular convolution. So circular convolution for two sequences x1 n and x2 n is, so x the circular convolution represented by this. So the circular convolution endpoint DFT will be the multiplication in the frequency domain. So x1 k and x2 k is a endpoint DFT of x1 k n and x2 n. Okay. So another property is time reversal. So as already all of you know that x of k is endpoint DFT of x of n, and then what will be the time reversal of this? So if we take x of minus n point circularly, even or odd signal, so it will be the xn minus n. And what will be the DFT? Similarly, the DFT of this sequence is x of minus k. If we apply is equal to x of n minus k. Okay, if you apply endpoint time reversal, so similarly that will be the k point time. In similarly, it will reverse in frequency domain also. So conjugate, another one is complex conjugate properties. So x conjugate n, where the endpoint DFT of x conjugate of minus n will be the x conjugate n minus k. This one is an important property, and most of the questions related to this property only. Okay. So now let's move to the questions for this week. This is assignment 5. So first question is, if x of n and x of k are 8-point DFT pair, then x of 44 will be, what will be the x of 44? So how will we will proceed for this question? So all of you as know that according the periodicity property. So what will be the periodicity property of the x r n plus k is equal to x of k. Okay, for DFT, and where r is an integer also. So how we can put it like this? We will get 44. So where n is equal to 8, it is 8-point DFT. So n is equal, capital N will be 8. So what will be the factors? Will be the r. So if we multiply by 5, so we will get it 44. 5 8 is 40 plus 4, 44. So what will be this? It is equal to x of 4, where r is equal to 5 and it is an integer. So the correct answer is option D. Okay. Okay, so for the next question, if x1k and x2k are the endpoint DFT of x1 n and x2 of n respectively, then what is the endpoint DFT of n? And x of n is equal to 3x1 of n plus x2 n is, options are k is equal to x1k plus x2k. Option B is xk is equal to 3x1k plus x2k. And option C is xk is equal to minus 3x1k plus x2k. And option D is equal to 3x1k minus x2k. So anyone want to answer this question? Please answer this question, then we will solve this. Would you like to try for this question? Okay, so this is a linearity property of the DFT. This follows the linearity property of a DFT. So as you know that the DFT of a signal xk is equal to n is equal to 0 to n minus 1 x n e to the power minus j 2 pi by n k n. So here we have n is equal to 0 to n minus 1. What we have x of n? 3 x 1 n plus x2 of n e to the power minus j 2 pi by n k n. Then if we open this bracket, then it will go for both 3x 1 of n e to the power minus j 2 pi by n kn plus summation n is equal to 0 to n minus 1 x2 of n plus this part e to the power minus j 2 pi by n kn. So this is a constant factor 3 and here is 1, so it is not taken. So if we take outside this 3, then what will be this is a DFT of x1k, because what is the sequence of n is equal to 0 to n minus 1 x1 of n e to the power minus j 2 pi by n kn. So it will be the x1 k, and similarly for this x2 of k. So what is the correct answer after solving this? So option B is the correct answer for this. Okay. Okay, so moving to the next question. The first 8 points of the 8-point DFT of a real valued sequence are 8, 2 plus 3j, 12, 36 minus 24j, 5, 36 plus 24j, x and y. Then what will be the values of x and y respectively? So option A is 12 and 2 plus 3j. Option B is 8 plus, and 2 plus 3j. Option C is 12 and 2 minus 3j. And option D 2 minus 3j and 8. So we already gone through this question, but included for this session. So this is a complex conjugate property of a DFT. So how we will solve this question? So n is equal to 8. This is a 8-point DFT. So already we know 0, 1, 2, 3, 4, 5. We don't know the 6 and 7 value. And that 6 and 7 value is 6 one is x. So we need to find out x of 6 and y is equal to x of 7. Then how we will find this? So x conjugate of 8 minus 6 is equal to x conjugate of 2. And what is the value of 2? 0, 1 and 2. This is a 12. Similarly, we need to find out the x of 7, that is the value of y. So this will be the x conjugate of 8 minus 7, that is a x conjugate of 1. What is the x of n? This is 2 plus 3j, and the conjugate of this 2 minus 3j. Okay, so what is the correct answer? 12, x is equal to 12 and y is equal to 2 minus 3j. So option C is the right answer. Okay, are you getting? Anyone can answer? Okay, so moving to the next question. If a sequence x of n is real and even sequence, then DFT of the given sequence is. So already we have gone through the properties of the symmetric DFT of a sequence. So if sequence is real and even, then what will be the DFT of this sequence? This is option A, x of k is equal to n is equal to 0 to n minus 1, x of n sine 2 pi by n kn, or xk is equal to 0 to n is equal to 0 to n minus 1 x of n cos 2 pi by n kn. or option C is equal to x of k 1 by n is equal to 0 to n minus 1 x of n sine 2 pi by n kn, and option D is 1 by n is equal to 0 to n minus 1 x of n cos 2 pi by n kn. So the sequence is real and even, so it must be follow the x of n is equal to x n minus n, and this is a real and even, so imaginary part will be equal to 0. So if imaginary part will be equal to 0, so what will be the answer? So in this sequence, the imaginary part is 0. So what left? N is equal to 0 to n minus 1 x r of n, that is the real part, cos 2 pi kn divided by n. Okay, so the correct answer is this. Here x r n represent the real part. Okay, so option B is the correct answer. And already we have described this in the properties part, DFT property, symmetricity property. Okay, so this is also related to that one also. If a sequence x of n is imaginary and odd sequence, that nature of the DFT of a given sequence will be, what is it? Purely real, purely imaginary. Option C is both real and imaginary, and option D is none of the above. So if sequence is imaginary and odd sequence, then the nature of the DFT will be the purely real, because if we will multiply, uh, have you seen that there will be the j part if again the sequence is imaginary and odd sequence, then sequence will be the purely real only. Okay. Okay, so moving to the next question. Consider a sequence x1 of n is equal to 0, 1, 2, 3 and 4, and x2 n is equal to 0, 1, 0, 0, 0. Then determine a sequence y of n such that y of k is equal to x1k multiplied by x2k, where x1k and x2k and yk are the DFT of the sequence x1 of n, x2 of n and y of n respectively. So already we have seen that the circular convolution property, if two sequence is circularly convolved, then in the frequency domain they are multiplication of the two signals. So how we will go through the discussion? Already we have gone through the circular convolution and another how to solve this question. First, there are different types, different ways to solve this problem. So what is the quick and easiest way to solve? First one, you can take a matrix convolution. I hope you all of you gone through the matrix convolution part also. So first one is, you can first calculate x1 of k, then find out x2 of k of x, this sequence and this sequence, then multiply x1k and x2k. And another one is, you can take a matrix convolution one. So I will be solving here the matrix convolution part. So let's see how we can solve this problem. Okay, this is a 5-point DFT. So we cannot find out directly for that formula 1 1 1 1, then, because this is applicable for 4-point DFT only. So in order to solve the 5-point DFT, we will go through the matrix convolution part. Okay, So 0, 1, 2, 3, 4. Then we will take that 4 in the up, then the sequence 0, 4, 0, 1, 2, 3. Then 3, 4, 0, 1, 2. Then 2, 3, 4, 0, 1. Then 1, 2, 3, 4, 0. And multiplied by x2 of n. That is 0, 1, 0, 0, and 0. Have you solved for this method? So just multiply row with the column, then we will find out y of n directly. So that will be the 0, 4 into 1, 4, plus all are 3 into 0, 0, 2 into 0, 0, and 1 into 0, 0. So 0 plus 0 plus 0. And 1 into 0 will be the 0 only. And this will also 0 into 1, 0. And all the parts will here 0. Similarly, multiply third row to this column. 0 plus 1 plus 0 into 0, 0, 4 into 0, 0, and 3 into 0, 0. And multiply fourth row into this column. So 0 plus 2 into 1, 2, plus 0, 0, and 0. And 4 into 0, 0. The last row to this column. 3, 0, plus 0, plus 0. Okay, now add these sequences, then you will get the y of n. So here 4 only, and there is a no. So 0, 1, 2, and 3, because all the parts are 0, 1, 2, and 3. Okay, so the sequence is y of n is 4, 0, 1, 2, and 3. So option is the correct one, the correct answer. So have you got this question, or do you have any doubt? Okay, great. Okay, so moving to the next question. This is also one of the properties related question. Let a discrete time signal be given as x of n with its DFT x of k, then DFT of a circular time shifted sequence x n plus m is circularly convolved endpoint DFT can be expressed as. So already you know that what is the formula of DFT. So x of k is n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n k n. Okay, so this is the endpoint circularly even signal, circularly time shifted sequence. So x of n will be the n is equal to 0 to n minus 1 x n plus m e to the power minus j 2 pi by n k n plus m. N is equal to 0 to n minus 1. We can take n plus m is equal to L also, or otherwise capital or and the changes, or otherwise we can follow the periodicity property of x of n is equal to x of, because this is a n point circularly times it, so x of will be the x of n only. And if we break this part, this will be the e to the power minus j 2 pi by n k m. Okay, so as already you know that this part is equal to x of k and multiplied by this part k m. So what is the correct answer? So correct answer is x n plus m. So there will be the minus j. So correct answer will be the A only. There is a, this one will be the A correct answer. X of k e to the power minus j 2 pi km by n. Okay. So this is this will be the correct answer. Do you have any doubt, or we can move to the next question? Okay, so moving to the next question. So if x of n is a real 5-point sequence and its 5-point DFT is x of k, where x of 0 is equal to 2, x of 1 is equal to 2 plus 3j, and x of 2 is equal to 4 minus j, then determine the value of x of 0, that is a small x of 0. So this will be the inverse DFT. So already x of 0, x of 1, x of 2 is given. What are this is n is equal to 5-point DFT. So we need to find out x of 3 and x of 4 also. So first we need to find out x of 3. How we will find out? The conjugate, that property x n minus k. So this is a 5-point DFT. So n is equal to 5. Here x, so x conjugate of 2. So x of 2 is equal to 4 minus j. So x conjugate of 2 will be the 4 plus j. And similarly x of 4 we can find out x conjugate of 5 minus 4, that is x conjugate of 1, 2 minus 3j. X of 1 is equal to 2 plus 3j. So x conjugate of 1 will be 2 minus of 3j. So this is it. We need to find out x of 0. So already you know that what is the inverse DFT formula. X of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k e to the power minus j minus, no, this is one is plus 2 pi by n k n. So we need to find out x of 0. So n is equal to 0. So this is a 5-point DFT. So 1 by 5. K will be 0 to n minus 1. That will be the 4. X of k, where k varies 0 to 4. And here n is equal to 0. So whole part e to the power 0. That will be the 1 only. So now we need to summation of all the x of k's. So 1 by 5. So if we will put k is equal to 0, so x of 0, the value of x of 0 is 2. Similarly, if we put k is equal to 1, so x of 1, the value of x of 1 is equal to 2 plus 3j. if we put k is equal to 2, so value of k is equal to 2 is 4 minus j plus value of x of 3. What we find out? 4 plus j plus x of 5. If we put x is equal to 4, so x of 4, what we find? X of 4, 2 minus of 3j. Okay, so if here we will check here plus j and minus j will be cancelled, and minus 3j and 3j will be the cancel. So 1 by 5, so 2, that is 2 plus 2 4 plus 4 8 12 plus 2 14, that will be the 14 by 5. So the correct answer will be the D, that is a 14 by 5. Okay. Okay, so have you got this question? Okay, so moving to the next question. So for the above problem, that is question number 8, what will be the energy of the sequence? Already have you gone through the Parsevals theorem? That is, in order to find out energy of a sequence, is 1 by n summation of k is equal to 0 to n minus 1 mod x of k square. Okay, here n is equal to 5. Already in the above question we have seen there's a 5-point DFT. So here 5-point DFT, so n is equal to 5 and the k varies, k is equal to 0, n minus 1 is 4. So mod of xk square. So if we put k is equal to 0, so mod x of 0 square plus x of 1 square plus x of 2 mod square plus so on, x of 3 plus x of 4. So 1 by 5. So just calculate this. So x of 0 is 2 only, so 2 to the 4, and x of 1 is 2 plus 3j. So what will be the value of 2 plus 3j square? 4 plus 9, 13. Okay, root of 13. So root of 13 square will be the 13 only plus 4 minus j. So 4 square plus either root of 4 square plus 1 square. Already you know that how to solve this one for complex signals. So root over real part plus imaginary part. So 4 square plus here only j, so 1 square. So 17. Root of 17. Root of 17 square only 17 plus 0, 1, 2, then 3 and 4. So this is a complex conjugator other part. So that will be the equal only. So 13 plus 17 only. So 1 by 5. Just calculate this. 30, 30 plus 60, 64. So 64 by 5. So correct answer would be B only. So here is the answer wrong. So this is the correct answer, 64 by 5. Okay. So have you got this question, how to solve this one? How we are solving for imaginary part. So let's say x of n 1 is equal to 2 plus 3j. So in order to find out mod of x1 square, so just root of 2 square plus 3 square, you know that how to solve this one. So 4 plus 9, 13, root of 13. So square of this, so we will get 13 only. Okay. And similarly for 1, 4 minus j and 4 plus j. Okay. So can we move to the next question? Have you got this one? Hello. So are you able to see my presentation? Because it's stopped, I think, somewhere. I don't know. So, okay, now my presentation is visible to all of you. Okay. Okay. Okay, now is it visible to all of you? Okay. Okay, so moving to the next question. So consider the following statement for an n-point DFT x of k of the real valued discrete time sequence x of n. Which of the statements are true? Option A, x of 0 is equal to n is equal to 0 to n minus 1 x of n. And option B is x n by 2 is equal to n is equal to 0 to n minus 1 minus 1 to the power n x of n for n being even. And option C, x of k is equal to x conjugate n minus k. And option D, all of the above. So any of you can answer this question? These are the properties of the DFT. So consider the following statements for n-point DFT x of k of a real valued discrete time sequence x of n. So what are the statements which are true? So already know that what are the DFT of x of n. It is defined as n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n kn. If we need to find out x of 0, k is equal to 0, then what we will get? N is equal to 0 to n minus 1 x of n. Here k is equal to 0. So this whole point will be the 0, e to the power minus j0. And what is the value of e to the power minus j0? With the 1 only. So n is equal to 0 to n minus 1 x of n. We will get x of 0 is equal to this. So the first statement is true. That means okay. And similarly x n by 2, where n being even. So let's take any value, the 4-point DFT or 8-point DFT. So if we will consider 8-point DFT where n is even, so n will be the 8 only. So that will be the 8 by 2. So n is equal to 0, n minus 1 will be the 7 minus 1 to the power n x of n. Okay, so let's try to do this one, x of n e to the power minus j, this part. So if n is very 0, so minus 1 to the power 0, so x of n only. And if we take n is equal to only for n is equal to even, so this equation will be, when we will consider minus 1 to the power 2, so 1 only xn e to the power minus 2, this will become xn by 2 is equal to n is equal to 0 to n minus 1 minus 1 to the power n x of n. N will be the any sequence. So this one will be the also holds true. And you know that option C, xk is equal to, this is the conjugate symmetry property. Xk is equal to x conjugate n minus k. We have solved so many problems related to this property. So this one is also true. That means all of the above statements are true. So option D is the correct answer. Okay. So moving to the next question. So question 11 is also related to the linearity property of a DFT. Already we have solved one question of this type. So again we are going to solve this one. If x1k and x2k are the endpoint DFTs of x1 and x2 of n respectively, then what is the endpoint DFT of x of n is equal to 2x1n plus 5x2 of n. So already we know that what is the DFT of xn. N is equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n k n. So n is equal to 0 to n minus 1 x, n is equal to 2x1 of n plus 5x2 of n in brackets, because it is a value of x of n, minus j 2 pi by n k n. So if we open this bracket, then we will get n is equal to 0 to n minus 1 to x1 of n e to the power minus j 2 pi by n k n plus n is equal to 0 to n minus 1 5x2 of n plus multiplied by this part e to the power minus j 2 pi by n k n. So here 2 and 3, 5 are the constant. If we can put outside of this summation also, then what is the whole part x1 of n e to the power minus j 2 pi by n k n, it is equal to x1 of k. What is the formula of DFT? And similarly for this also, plus 5x2 of n. There is some problem, I'm not able to write it. So 2x1k plus 5x2 of k. So which option this is matching? Option C is the correct answer for this one. 2x1k plus 5x2k. Okay. Okay. So moving to the next question. Okay. So next question will be, if x1 is a real and odd, then what is the IDFT of the given sequence? So if x1 is real and odd, then what will be the IDFT, inverse DFT of the given sequence? So option A is J, 1 by n, k belongs varies to k is equal to 0 to n minus 1, x of k sine 2 pi nk divided by n. Option B is 1 by n, k is equal to 0 to n minus 1, xk cos 2 pi by n, nk. And option C is minus j, 1 by n, k is equal to 0 to n minus 1, xk sine 2 pi by n, nk. And option D is none of the above. So the xn is here, xn is real and odd. So what will be the IDFT of the sequence? So already we know that the IDFT formula is related to, I am not able to, my pen is not working, so I will explain it verbally. I will try to write it later. Okay. So IDFT, as you know, that x of n is equal to 1 by n summation n is equal to 0, k is equal to 0 to n minus 1, xk e to the power minus e to the power j 2 pi by n k n. So the xn is real and odd, so that will follow x of n is equal to minus x n minus 1. We can see here, and here in the it is real and odd, so real part will be the xrk will be the 0, so xk will be the purely imaginary and odd, and this will reduce to the IDFT of the sequence will be reduced by this function. Okay, so here we will get this sequence. X of n will equal to j 1 by n, k is equal to 0 to n minus 1, x of k sine 2 pi by n and k. Already we have seen the previous one, the real part and imaginary part. If the real part will be equal to 0, then we will get this one only. Okay. Okay, so moving to the next question. Determine the circular convolution of the sequences x1 n is equal to n del n plus n del n minus 1 plus n del n minus 2 plus del n minus 3. And x2 of n is given 2 del of n plus 3 del n minus 1 plus 4 del n minus 2 plus del n minus 3. So what would be the x1 of n? x1 of n, what will be the sequence values here? N is equal to 0. We will take it like this. Here del n is equal to n, at n is equal to 0, n. So what will be the value of n? That will reflect here. So n is equal to 0. So 0 will be there. Then at n is equal to 1. So the value of at n is equal to 1, n, so n will be the 1 only. Whatever value is n is equal to 2, so the value of n will be the 2, then 3. Okay, so whatever value is n here, n is equal to n minus 3, so n is equal to 3 only. So we will take it like this. And similarly for x2 of n, here the values are given at del is n is equal to 0. The amplitude will be the 2, then 3, 4 and 1. So these are the sequences x1 of n and x2 of n is given. Then we need to find out the circular convolution. So all of you already know that how we will find the circular convolution of the sequence. Here x1 of n. So what is the values of x1 of n? 0, 1, 2 and 3. Here the 0. And similarly we plot x2 of n. So at here it is a 0, 1, 2. We will move like this in a clockwise direction. So 2, 3, 4 and 1. Now what we need to find out? We have to take x2 of minus 1. x2 of minus 1. So now this one is x2 of n. So we will move into the x2 of n. So it will be the move anti-clockwise direction. 2, 3, 4 and 1. Okay. So now we have to move, we need to find out x1. Already you know that what is the circular convolution formula. X2 1 of n multiplied by x2 of n minus n. Okay, so multiplied and n varies. N is equal to 0 to the value n minus 1. Okay, so I am going to remove this, then we will otherwise we can take a new slide, then we can calculate this one. Okay, so first we need to find out x3 of 0, where x3 is a convolution of x1 of n plus x2 of n, circular convolution. So for getting x3 at 0 point, so we need to take x1 of n, here x2 of 0 minus of n at the 0 point. So x2 of minus n at n is equal to 0. So just we need to multiply x1 of n multiplied by x2 of minus n. So what are the values of this? So 2 multiplied by 0. So 0 multiplied by 2 plus 1 multiplied by 1. So 1 plus 2 multiplied by 4. So 2 4 is 8 plus 3 multiplied by 3. So 3 3 is 9. So 9 and 8 plus 1. 9 9 18. So at 0th point we will get 18. So first sequence will be the 18th. Similarly, we need to find out x3 of 1 equal to x3 of 2 and x3 of 3. So just I am writing here, then so that we can able to calculate easily. x1 of n will be the, just a minute, here 0, 1, 2 and 3. This one is x1 of n, and already we have calculated, so x2 1 minus n. Okay, so just we need to shift 1 point x2 of n. So what will be the sequence? Will be the 3, 2, 1 and 4. Move to the previous slide. As we know that x2 of minus n is 2, 1, 4, 3. If we move one rotation, so here 3, 2, 1, 4. Okay, we will get 3, 2, 1, 4. Now, in order to get x3 of 1, we will multiply these two sequences. So 0 into 3, so 0 only, 0 plus 2 into 1, 2 plus 2 into 1, 2 plus 4 into 3, so 12. 12 to 14, 16. We will get 16. Here 18, here 16. Similarly, x2 1 minus n. So now we have to move x2 in 2 points. So x2 2 minus n. So what we will get? If we move one rotation more, so 4, 3, 2, 1. Now multiply with x1 of n. So 4 into 0, 0 plus 1 into 3, 3 plus 2 into 2, 4 plus 3 into 1, 3. So what we will get? 3 plus 3, 6 plus 4, 10. Similarly, in order to find out x3 of 3, so we will rotate the sequence 3 times. x2, 3 minus n. So again we will rotate x2, 2 minus n one time more. So 1, 4, 3, 2. Okay, so what we will get? 0 multiplied by 1. So 0 plus 4 into 1, 4. 3 into 2, 6 plus 2 into 3, 6. So 6 plus 6 plus 4, 16. So what the sequence we will get? x3 of n, we get 18, 16, 10, 16. Okay, so these are the sequences: 18, 16, 10, 16. So what will be the correct answer? So option A is the correct answer: 18, 16, 10 and 16. Okay, so have you got this question to how to solve? Okay, so moving to the next question: if xn and xk are the 8-point DFT pair, then x2 plus 8 will be the. So this is also one property. Hello. So yeah, hello. This is a also circular array convolution property. So x 2 plus 8 or x n plus k will be the nk. So what will we get? X of 2 only. Here it is a 8-point DFT, so it will be the n only. Okay, so option C is the correct answer for this question. If xn and xk are the 8-point DFT pair, then the value of x2 plus 8 will be there. Okay, so moving to the next question. If x of n is a real 5-point sequence and 5-point DFT is x of k, where x of 0 is equal to 4, x of 1 is equal to 1 minus 2j, and x of 3 is equal to 3 plus j, then determine the value of x of 0. So what it will be the value of x of 0? Already we have solved one problem. So again, here n is equal to 5 and x of 0, 1 and 3 we know. We need to find out x of 2 and x of 4. So how we will just first we need to find out x of 2. So x conjugate of n minus k, as we know that x conjugate 5-point DFT, so 5 minus 2 is equal to x conjugate of 3. What is the value of x of 3? 3 plus j. So we will get 3 minus of j. Similarly, for x of 4, x conjugate of 5 minus 4, we will get x conjugate of 1. So x of 1 is 1 minus 2j. We will get 1 plus 2j. Okay. So already we know that inverse DFT formula x of n is equal to 1 by n. Summation of k is equal to 0 to n minus 1 x of k e to the power j 2 pi by n k n. Here n is 5-point DFT, so n is equal to 5 and k is equal to 0 to 5 minus 1 is 4. Here we need to find out value of x of 0. Okay, so this part will be the 1 only, so this will be the x of k e to the power, all those is 0, so e to the power is 0 is 1. Okay, 1 by 5 summation of all the components. K is equal to 0, k is equal to 0, so x of 0, so x of 0 is 4 plus if k is equal to 1, x of 1, x of 1 is 1 minus 2j. If k is equal to 2, then value of x of 2 we got it 3 minus j. Then x of 3, if k is equal to 3, x of 3, then 3 plus j plus x of k is equal to 4, then x of 4 will be the 1 plus 2j. So here some parts will be the cancelled out. Then we will find 1 by 5, 4 plus 1, 5 plus 3, 8, 8 plus 3, 11 plus 1, 12. So 12, we will get 12 by 5. So x of 0 is equal to 12 by 5. So here we will see option A is the correct answer. Here we are getting 12 by 5. Okay. Okay. Moving to the next question. So x1 of n and x2 of n are two sequences of length 4 and circular convolution is computed using equation 1, that is, in which of the following figure represents x2 2 minus n. So x1 of n is given and x2 of n is given, and how we calculate the circular convolution is also given. So let's see first what is the sequence of x1 of n. So 3 del of n. So at n is equal to 0, the value is 3. Here there is nothing at n is equal to 1. So it will be the 0 only. At n is equal to 2, the value is -2. And at n is equal to 3, the value is -5. So this is a sequence of x1 of n. Then we need to find out the sequence of x2 of n. So let's see. So at n is equal to 0, value is 1. At n is equal to 1, value is -3. At n is equal to 2, there is a nothing. So it will be the 0 only. At n is equal to 3, the value is 2. Okay, so these are the sequences of x1 of n and x2 of n. Now we need to find out the circular convolution of this, that is represented as x3 of n, x1 of n, circular convolution of x2 of n. That is represented here. We need to find out x2 2 minus n. So let's plot x2 to 1 -3 0 and 2. So this is a sequence x2 of n in the circular convolution. Now already you know that first we need to find out x2 of minus n. So how we will get it? Just rotate it anti-clockwise. 1 -3 0 and 2. Now here 2-point circular set is there. So just rotate this in the 2 point. Then we will see which option it is matching. Okay, if we rotate in the 2 points, then this 0 will come here. 0, then -3, then 1, and then 2. Then every point will be rotated at 2 points. So what will be the correct answer? This is a rotation of x2 2 minus n. Okay, so let's check option A. No, this one is wrong. Then check for option B. So this seems to be a correct answer for this question. So the 2-point rotation of x2 n will be the 0, -3, 1 and 2. So option B is the correct answer for this question. Okay. Okay, so moving to the next question. H of n is the impulse response of the FIR filter of order 62, and if the xn signal of length 320 is applied to the input of the filter, determine the minimum length of the DFT to compute the filter output in the frequency domain. So if there is a two signal xn and h of n given a length, let's say sequence x of n is length n and h of n sequence length is m, then what will be the output? What is the total length of this output signal? Already you have gone through that. What will be the total length of these two signals? So you know that n plus m minus 1. The output length of the output DFT will be the, let's represent any value. The length of the output must be greater than equal to n plus m minus 1. So here the n is the length of the signal x of n, that is the signal, that length is 320, right? And length of h of n is represented by m. So the length of the FIR filter is 62. and minus 1. So this must be greater than equal to. So 2, 8, 3 minus 1. So this must be greater than 382 minus 1 will be the 381. So option A is the correct answer. The length of the output signal in the frequency domain must be greater than equal to 381. Okay. How will you find n plus m minus 1? This is the formula of the measuring the length of the DFT signal in frequency domain. Okay. Okay, so moving to the next question. Have you got this question? Okay, so moving to the next question. Let x of t be an analog signal with bandwidth b is equal to 3 kHz. We wish to use an n-point DFT to compute the spectrum of the signal with resolution less than or equal to 20 Hz. Determine the minimum value of n. So here bandwidth, that is b, is given 3 kHz, and the resolution, that is represented as n, is given for an n-point DFT, or you can write it, n is already given, so we can write resolution. Resolution is given 20 Hz. So here we need to find out minimum value of n. So how these terms are related to each other? So there is a one formula, resolution is equal to 2 into b divided by n. Okay, 2 multiplied by bandwidth divided by n. So here resolution is given, bandwidth is given. We need to find out the minimum value of n. So resolution is 20 Hz and bandwidth is 3 kilohertz. 2 into 3 kilohertz divided by n. So 6 into 10 to the power 3 divided by 20. So we will get here, if we divide it 300, we will get. So minimum value of n will be the 300. Okay. If you 2, 3, here 1 0 will be the getter, so 100, so 300 only. Okay. Okay, so have you got this question? We can move to the next question. So okay, so this is option B is the correct answer for this question. Okay, so moving to the next question. So we have solved this type of question already. Again, we are going to solve this. First, 5 values of 8-point DFT of a real valued sequence are as given below. X of 0 is given 3, x of 1 is given 2 plus 3j, and x of 2 is given equal to 0, x of 3 is equal to 3 minus 5j, x of 4 is equal to 6. Determine the energy of a sequence. Here it is also n is equal to 8-point DFT, so n is equal to 8. So we need to find out the other values, that is x of 5, 6 and 7. 3 values are left. So first we need to find out x of 5. So x conjugate of n minus k. So what will be the 8 minus 5? That will be the x conjugate of 3. What is the value of x of 3? So x of 3 is 3 minus 5j. So conjugate of this 3 plus 5j. Similarly, we need to find out x of 6. X conjugate of 8 minus 6, that will be the x conjugate of 2. The x of 2 value is 0, so that will be the also 0. And similarly, x of 7, x conjugate of 8 minus 7, that will be the x conjugate of 1, that is x of 1 is 2 plus 3j, so that will come 2 minus of 3j. So now, in order to find out energy of any sequence, already told you energy is equal to 1 by n summation k is equal to 0 to n minus 1 mod of xk square. So here n is equal to 8, so 1 by 8 summation k is equal to 0, n minus 1 is 7. Now x of k square. So now we will put k is equal to 0, 1, 2 up to 7, then calculate x mod of k. So if we put k is equal to 0, so mod x of 0 value will be the square. So that x of 0 is 3 only, so 3 square is 9, plus similarly x of 1 mod of x of 1 square. So first x of 1, this is a complex conjugate signal, so 2 under root 2 square plus 3 square square. So 4 plus 3 root of 3, 13 square, so 13 only. Similarly, x of 2 is equal to 0, so 0 plus, if we put x is equal to 3, then x of 3 mod of x of 3 square, so what we will get, root of 3 square plus 5 square. What we get, the value, can anyone calculate it? 3 square plus 5 square, 9 plus 25, right? Root square, that is 34. Okay, similarly, if k is equal to 4, then root 6 square, so 36. Again, x of 5, that is 3 plus 5 square, 3 plus 5j. So what will we get? 34 only. 3 square plus 5 square root. Then x of 6 is 0, so 0 only, and x of 7 2 minus 3j. So again it will be the 13 only. Okay, so 1 by 8 summation of all these points. So what we will get, if you sum all these points, 9 plus 13 plus 34 plus 36 plus 34 plus 0 plus 13, you will get 139, right? So the answer will be the 139 divided by 8. So what will be the correct answer? The correct answer is option A, 139 divided by 8. Okay, great. So have you got this question? Okay, so moving to the next question. So this is also property related question. If xk is n point DFT of sequence x of n, then what is the DFT of x conjugate of n? This is the x conjugate of n. Conjugate of n. So already you know that in the properties of DFT, f x conjugate n minus k. Okay, so DFT of x conjugate n, x conjugate n minus k. So option C is the correct answer. Okay. Okay. So now moving to the next question. Hello. Okay. So I think this question related to you, Sirisa. Are you able to see and last week you have asked this question. So I have not solved this question properly, but I am going to give you how to solve this question. Then if you are not getting after doing this, then you can ask me the next. Otherwise, just I am going to give you the whole overview how to solve this question. Okay. So the question is output signal of LTI system was analyzed with sampling frequency fs is equal to 16 kilohertz and obtained the following information. The first resonant frequency f1 is equal to 288 hertz and bandwidth is equal to 95 hertz and the second resonant frequency f2 is equal to 719 hertz and bandwidth 2 is equal to 75 hertz. If the system is modeled using all pole model, determine the transfer function of the above LTI system. Choose the option that closely matches with your result. So here we need to find out the pole at which frequency the poles will be there. So here sampling frequency is given 16 kilohertz. So already you know that how to represent the all pole system. Sir has told you, I think, in the pole zeros part in the jet transform. So all pole system, let's U of z is represented by where g is a constant and k is equal to 1 to n by 2, 1 minus 2 rk cos theta k z inverse plus rk square z to the power minus 2. Or if there is a pole, for example, this is a ROC of Z transform and there is A1 and A2, they is related to theta and this one is R1, right? So it can be like 1 minus AK, let's represent a RK, e to the power minus theta, j theta, you know that how to represent. And there is a one complex conjugate of this signal e to the power j theta 1. It can be represented as also like this. So now how you will solve this problem? So the all pole system is represented by this formula only. Okay. So now first the sampling frequency is given and resonant frequency as 2 points is also given. So already you know that the formula, I think you if you have gone through the lecture videos, there is a one formula where the value of theta k is represented by resonant frequency, is related to the resonant frequency. Okay, here frequency and value rk is related to the bandwidth, to the this bandwidth. So here the all the values are given in the hertz. So in order to calculate this r and theta k, we need to find out these values in terms of radian per second, in radians, right? This is a rk and the angle associated with this in theta k. We need to find out these poles on inside the Z transform inside the circle, right? Right, Sirisha? Here in this question. Okay, so just first remember that theta k is related to the resonant frequency and value Rk is related to the this bandwidth. Okay, so now these hertz values we need to first transform in radians. Okay, so how we will transform this? This is sampling frequency is given. So you know that 2 pi by, in order to transform for 1 radian per second 1 by fs, that formula 16 kilohertz. And here we are going to translate first that resonant frequency that is related to theta. So 288. So Sirisa, can you calculate this? Here it is a theta. So here we need to take pi in the terms of 180. If it is the other values, for example, we are going, if we are find out the R1, this is related to angle, so here we need to find out the angle. So in that case pi we will take 180. If we are getting the value of r1 here that is related to this, not an angle, then we will take 3.14. okay, pi equal to, so first calculate 2 pi by 16 10 to the power 13 into multiplied by 288. What you will get? 6.48, right? Okay, theta 1 we will get. Similarly, you have to calculate for second resonant frequency. Okay, then here the value, here the bandwidth is also in hertz. So we need to calculate in the radians also. So similarly, we have to calculate this. For example, take it like BK. So 2 pi by Fs, that is 16 kilohertz, multiplied by 95 hertz, then what we will get? Just can you calculate this? Here we need to pi 3.14 because it is not an angle. Okay, so just calculate it. Then in order to find out this value R k, it is e to the power minus of dk. Sir has given this formula in the slide. So first calculate Vk in this term, then get Rk. 0.037, right? And e to the power minus dk, what you get? I think 1.037. Okay, are you sure? 1.037. Okay, and okay, again, already told you what is the formula of this all pole system. So just take it, this is a arc, na? So first take it as a 1, B1 and R1, and put in that formula, that is G is equal to 1 minus 2 R1 cos theta 1 Z inverse plus R1 square Z to the power minus 2. Then you will get the some frequency. Then you have to choose an option which is closely matches with your result, right? So just take, if it is coming any of these values, any of these. So now G divided by 1, what is the R1? R1 is 1.037 multiplied by this 2. So you will get multiplied by 2 and cos theta 1. Theta 1 is 6.41. So what will be the cos 6.41? 48. What will be the value of cos 6.48? And multiply these values and put in this formula, then find out pole, and again you need to convert it again into hertz. So remember this, we have converted it into the radians, right? In the hertz. Then check whether you are getting any answer related to this, and again you have to find out the r1 you have find out, again you have to find out the r2, theta 1 b2. It's opposite to here we are multiplying by 2 pi, divide by 2 pi. Okay, sir. Huh, huh. First you try, I have given you overview how to solve this question. Okay, then find out it, and let me know if you are facing any issue. Yeah, okay, okay, great. So find out the theta 2, B2 and RK, then put it in this all pole system formula and find out the poles values. You know that how to find out that equation and poles in the transfer function. Then you will, I think, hopefully you will get this answer. Okay, then the questions are completed. So if you have any doubt, let me know. Otherwise, we can close this session. Okay, okay, okay. Yeah, sure. So, okay. Thank you, everyone. Thank you. Thank you for this. Okay.